So the tech behind it all. Where do you think we're going with the tech behind it all? What's the tech behind all of this? And I think you'll be surprised. It's not what you expect it to be. So we're going to start looking in a different area. Someone just described himself as a cuckoo, which was interesting way of looking at it. But in a way, I also understand it. But this is one of the areas we've been talking about earlier. Where is this all going? Is this complementary? I think it's very complementary to some of the things that have been discussed earlier. How do you get backhaul? How do you get where you need to be? How do we cover these rural areas? How do we get there quicker? How do we give them the speeds? So we're going to go into an area that I know the SCTE has been looking at for years, which is 5G. How are we going to get there? How we can help? How we can actually complement each other? Prepared for that? Yeah. So Mark, you get the first part.
Thank you.
Remember, it's just after lunch, so.
Yeah, I mean, when they told me that I'd be doing this graveyard, I was slightly nervous actually. So hopefully I can keep you awake. There's a lot of slides here, so I'll canter through. But yes, I'm going to try and talk to you about some 5G technology and private networks. So, I mean, colleagues this morning have told us how wireless isn't really that helpful for broadband, and we all want fibre, but yeah, sometimes the wireless technologies will come to the rescue. And I'm very lucky to have a colleague I've worked with for over 20 years, Malcolm Brew from the University of Strathclyde, who's working as an engineer at Neutral Wireless, which is a university spin-off in Glasgow. So I'm going to hand over to Malcolm halfway through this presentation, so you don't get bored with the same voice. So we can discuss, well, what is 5G and what is 5G SA and NSA, in case people don't know. And what have we got in the UK in terms of mobile broadband infrastructure, and what are the problems with it, if any, or is it all perfect? Is it, who here thinks their mobile broadband experience is perfect? Anybody? No hands, right, good. And then some stuff on private 5G, which is what I've been working on. I actually work on, there's two strands, I work for BBC R&D, and there's two strands of research at R&D. There's the distribution side, so we're interested in 5G and broadband networks for distributing our content on things like iPlayer and BBC Sounds. But we also use wireless networks for making content, and that's where where my research is focused. And in the last 4 years, it's been focused on the use of private 5G networks for projects, making programs. So we discussed some of the applications of private 5G, and we get onto some rural broadband projects that we've been involved in, and I'll swing over to Malcolm at that point and try and draw some conclusions from that. So there's quite a lot there. So people say, well, why do we need another G? You know, will there be a 6G? You know, what was 5G a disaster? And I just sort of think, well, these generations of mobile technology, these are just badges that are hung on the technology, and it changes every 10 years roughly. So every decade we get a new generation of mobile technology. So you can think back to the start of the millennium. You can think back, I mean, I didn't have one. I mean, I'm too young, obviously. But back in the day, you had analog bricks in your pocket if you were very, very well heeled, or in your car. And then we got the first GSM phones, that was 2G, and then another 10 years. We started to see the 3G connections, the BlackBerries, and some, you know, internet on the move, and then 4G, and of course we've moved on to 5G. And the idea is every 10 years you get a 10-fold increase in bandwidth and capability, and people say, well, can this go on forever? And the answer is probably no, but there's a whole industry looking at this, and it's not going to stop. So yes, there will be a 6G and a 7G, and who knows. So now the standalone and the non-standalone 5G. What do we mean here? Well, what we've ended up with in the UK is what I would say is 5G non-standalone networks. So you need both a 4G and a 5G network to get your connection. And what you'll find when your phone says 5G is that yes, the downlink traffic is coming on a 5G bearer, but all your uplink traffic is still on 4G. And we haven't got true 5G standalone networks. But where we were hoping to end up is a pure 5G network with a more sophisticated 5G core network, and this is going to support much, much higher bandwidths on the uplink, which is the sort of thing you need for cloud computing applications and program making functions and uploading your photographs, video calling, high performance video calling. This is what one day will be coming. But so people say, oh, well, 5G's not been very good, has it? I say, well, wait for 5G standalone and maybe you'll think differently. Now, mobile coverage. These ants, this is our best guess of the mobile cell site. So this is based on SiteFinder data from Ofcom 2010. And then the shutters were pulled down on that. So you're not allowed to know where the mobile masts are now. If you FOI Ofcom, they tell you it's national security, you can't know. But they've not changed much since 2010, so this picture is pretty much right, and this is one mobile network. And what you instantly notice about that is that mobile network operators will build infrastructure where there's population. And if there's no population, there's little incentive to build any mobile network out. So that affects coverage. So if you go to the Highlands of Scotland and the Northern Isles, where Malcolm comes from, you'll find there's not a lot of these black ants. There's a whole swathe of them between Glasgow and Edinburgh. But out towards the islands, there's virtually nothing, and the coverage is marginal. And this indoor coverage is very important to us in the BBC because indoor is often the same as in car, and a lot of the outdoor use case is in car. So yeah, you can sort of say, well, if I hold my phone up in the air outside, I get a bit of coverage, but quite often people are trying to get that coverage when they're inside their car and on the move. But these coverage holes, they're not peculiar to rural places. You also find that you've got coverage problems in big conurbations like London. So, you'll see light green, limited indoor coverage over a lot of that map, and you'll see these white holes of no coverage at all, even in a big sprawling conurbation like London. This is where I work at BBC Research and Development, Shepherd's Bush. We're just sort of down Wood Lane, just you can see Television Centre in the distance there. So there's the plan. We've got the A40 to the north. And if you look at the coverage, I'm working in London, but guess what? My phone barely works indoors. And the BBC can't afford a DAS system for the lighthouse. So people miss calls and they've got poor data coverage all of the time. And you can go on the Ofcom checker, I put in my postcode at work, and there we are. EE, limited voice, limited data. O2, some voice coverage likely, data coverage limited. This isn't a great picture, is it, really, for a major central population? And of course, where you've got thin coverage, you end up operating with very low signal-to-noise ratio, and the capacity of these networks falls away as you run to the edge of the cell. So you get a poor service, you get very poor coverage. And I often look at NetCell info on an Android, and the needle's down here in the red or the amber, and if you speed test it, it's pitifully thin. So there's a real problem in this country with indoor coverage. And the other thing is congestion. So there was an event This was CBS News. BBC used bonded cellular for getting pictures back these days, and the experience in Edinburgh was not
Dana,
good.
you can hear the excitement,
Here's
and
a
I'm sure
different
you can
experience.
see the excitement. Hundreds of people, maybe thousands, rushing to catch a glimpse of their king who just passed by.
So this was
in
a
state
private
coach.
5G network
Some
that
of
we
them
put
even,
up
they said,
for the
have
King's
lost that
coronation
stiff upper lip
in May
that they were
2023 with Neutral Wireless providing the infrastructure for us. So big difference. So how do we build networks like this? How do you build private 5G networks? Well, the important tool for you is the Ofcom shared access license. So Ofcom will license you spectrum, which is mobile spectrum. It's a 3GPP band, so your iPhone or your Samsung will work in this band. And this spectrum, 3.8 to 4.2 gigs, is available for licensing across the UK. We're just upstairs from all the operators in the N78 immediately below us, but there's 400 megs of spectrum here that's available for private networks. And there's lots of applications. The guys at Neutral Wireless have put up networks in Stadia. We've seen the coronation, and of course the guys in Scotland went on to provide 5G network connectivity for the Paris Olympics with lots of innovative applications. If you saw the opening ceremony or the sailing, these were done with private 5G networks. We get involved with all the planning aspects, planning the networks using Cloud RF and tools like that to do terrain sensitive coverage maps. And for the network on the Mall, it was installed by Neutral Wireless guys. We had continuous coverage for news networks and shared that amongst various news providers. We get involved in what I call tier 2 outside broadcasts. So if you've got some, low-level sports events, some basketball or some lower league football, these things get streamed, and we want to get those pictures back. So they're using a lot of wireless networks at those events. They're using 5G networks to connect up cameras conveniently. They might be fixed cameras, they might be moving cameras. And then we're using things like Starlink sometimes to backhaul from those sites because the connectivity is so weak at those sites and you just cannot get the fibre connectivity in good time. And my colleagues at BBC Scotland are actually doing quite a lot with Starlink. So we can get up to 10, 20 megabits of uplink on Starlink. There's outages, because as the satellites fly over, you'll find that there's a gap in the constellation and you'll see a 200 millisecond outage. So the sort of really low latency live events you can't exactly do because you've got to buffer your way through those outages. And they're currently building a vehicle where they're going to bond Starlink with OneWeb to improve the capacity and the reliability of that network. The other things that we're doing is we're often, this is bonded cellular, so this is a sort of bonded cellular bag that we used at the Commonwealth Games in Birmingham. And we're also putting multiple routers in briefcases. You'll see this has got an enhanced performance antenna in the lid of the briefcase. And instead of sending a truck to an event, we're sending a journalist with that briefcase to get the connectivity back from that event. I'm going to hand over to Malcolm now to talk about rural broadband.
So we started working off in rural broadband in the UK with BBC on some remote isles, on the Isle of Bute, where we were using shared spectrum. The use of primary users, BBC, or the primary owner of that spectrum, we were using low power secondary use of that spectrum. So that was the start of shared spectrum, and through that we found ourselves working with DCMS on one of the first 5G rural projects up in Orkney, which is at the time when we went to Orkney, I think it was the least connected rural set postcodes you can get in the UK. We did a lot of, we're kind of unencumbered or were out of the way of the bigger networks. So we actually teamed up with a local company, the university, and BBC, and we brought lots of tools to the locals. So up in Orkney, terrible storms, you have to build it and maintain it yourselves. So we kind of did a lot locally. Up in Stronsea was where we actually, I think this is where UK might have had its first 5G broadcast. BBC managed and ourselves with some of our software and radios. These were some UK's first outdoor trials of 5G for broadcast. It's very challenging designing rural broadband networks. You're tied up with all kinds of Ofcom rules, planning, council rules. It's an absolute. It's very difficult, and you've got a limited budget, and you have few people in a large area to try and kind of get some connectivity to, because they haven't got phone lines. They've actually got very little. So you have to go through this iterative process of basically working out where you can cover high sites. But what a good thing in Orkney, or lots of these communities, you actually want to work with the community, because suddenly land, all of the deals that some of the islands or communities are used to going into with O2 or EE, you can kind of fast track those, because everyone wants their broadband. Once you've done this iterative process, it just keeps on going back again, and it's actually very complicated and very slow, and planners' rules are changing all the time. And whilst you're doing this, BDUK or SRN, there's going to be an intervention that's going to bring an EE or a Vodafone that's going to disrupt your kind of well thought through plans. And so we know of lots of networks which have actually been built with great intention and great enthusiasm, which are kind of fall over at the end of the day when BT come to town, or come to the village rather than the town. And again, this is we'll speed through some of this. I don't need to. We have been working, as Mark says, for quite a while now, and we are software-defined radio guys. So we make everything from, not really with discrete components, we use software to make our radios, and use FPGAs to implement, to build these networks. So they're actually these are the networks that we've taken to Paris, King's Coronation, we've taken them to motorbike racing, we've taken them to major events. They're very compact, they're very lightweight, and the networks that we installed up in Orkney back in 2017, I think, then it was released, it was a bit of a scam, it was release 13, release 14, UK government were paying for 5G trials. 5G only really came about in release 15. So anyway, we started off on Orkney with a release 14 network, and that network, without us going to Orkney today, these base stations are running as a 5G release 18. And no fault lifting. Nobody went to the island. These have all been upgraded remotely from Glasgow with software. So the total cost of ownership of these software-defined networks, they're very capable, they're very low power, they're much cheaper than anything you could buy from a tier one. And I'd say that, and again, all locally maintained. They're built with, you can go onto Amazon and order the parts. The software you have to get from somewhere else, but the parts you can get off Amazon. Again, I think I'm not preaching to the converted, but these are local guys digging local holes with masts covering their post office, their library, their harbour, getting their ferries connected with connectivity. Again, these are local riggers. Everything that we do needs to be done needs to be done on the island. You can't. Sometimes you can't get to Orkney for 3 or 4 days, and some of the islands you're really stuck because they've small ferries and the weather is very inclement. So I think we're coming to the conclusions. So, Mark, what do you?
Yeah, I mean, I can walk through this. These were some conclusions I tried to draw here. I mean, I think we all agree that mobile isn't an optional extra anymore. People want this sort of connectivity. It's the internet in your pocket. That's what you've got with your iPhone and your modern smartphone. So it's increasingly vital to everything we do, from ticking things off on your shopping list in Sainsbury's to parking your car to everything you do. It's essential. And for me, the mobile network rollout it's expensive business. That's part of the problem, and it's difficult to justify it in the less dense populated areas. So we've ended up with a network which is very, very cheap. I mean, you can get a SIM card with huge data for less than £10 a month, but the coverage is often a bit limited, and it's often really lousy indoors as well. And the other side of the coin is the congestion. So in London, you've often got bars on the phone, but then you find there is no capacity on the network, and quite where that congestion is, whether it's in the RAN or in the backhaul, nobody really knows. That's all we know is it doesn't really do what we want to do at that moment in time. So for me, don't forget. I mean, I kind of get it what you guys are saying, and all this enthusiasm from the altnets is it's a joy to hear, but I think there are opportunities with 5G non-public networks, these private networks that can be deployed, and there's a chance that these can help both in where you need wireless connectivity over a wider area than Wi-Fi in rural areas, but also for sort of seamless roaming into indoor areas, which you can get connectivity indoors with Wi-Fi, but you're often navigating past these captive portals, and it can be a really frustrating experience to just get connected, and maybe 5G can help with that. So there's plenty of exciting applications, and what I've learned from working with the universities in Glasgow is there's a hell of a lot of expertise in this that's been built in the UK. It's not an accident that the Olympic Broadcast Services went to Glasgow to have their 5G networks built for the Paris Olympics. It's because we've got expertise in this country. So that's really it from me. Thank you very, very much. Thank you.
Are there any questions to that? Oh, looks like we're going to need microphones already. That was unexpected.
Do you want me to wait?
We've got one at the front here, and one at the back.
So who was it?
It's always Barn.
Okay. If you set up a private 5G network, is there an opportunity to interconnect with the public networks and sell your capacity to them?
So that was actually one of the things that we were paid under a DCMS project to do in Orkney. So technically, it's very easily done, and we went up there to prove this. But the MNOs are completely against the idea of any neutral hosting, or the idea that we could. That was in 2017. I think now their business isn't kind of sunset, but it's not super stoked as it used to be. So perhaps the CTO may say no, but the CFO, it is getting close that financially they are going to have to think again, because if we had a kind of a rural obligation properly pinned to these MNOs, as they were making all of this lots of money in their heydays, it would be really useful to have had a rural obligation, or them to be obliged to deliver services in places like Orkney or in these hotspots, because then we would find community groups or community networks being able to peer their traffic with the MNOs, and that's the best. That's everyone wins then. Vodafone actually win because somebody else is doing the power. They built the tower. They're maintaining it. They get traffic when their SIMs roam into this, and the locals get their own network where Vodafone wouldn't be. And when they leave their village, they're still connected on the network. So it can be done, but wow, the MNOs don't care for it, sadly.
I think the plan was for 5G New Thinking. They were thinking we will connect this network to a telecom core network, and they were trying to negotiate a deal with Faroese Telecom, who are a small mobile network that look after the Faroe Islands. And what would happen is if you lived on Orkney, you could have a Faroese Telecom SIM, and then when you went to the mainland, you'd roam onto the UK network, and you'd get the sort of super coverage you get when you go abroad, because you'd see all 4 networks on that roaming SIM. But for whatever reason, it stumbled. There's regulatory obstacles, there's business obstacles, and it stumbled. So the thing you can do easily is, and it's become easier with modern phones where you've got multiple SIM cards. I mean, simplistically, you could put in a SIM card for your private network and a SIM card for a mobile network. And you generally have to switch the phone between the SIM cards, which is a bit of a bind. But you could do that to get connectivity if you live somewhere rural. But it's getting easier. I think there's opportunities with eSIMs now. You can load up eSIMs, but it needs some sort of roaming deal with a mobile operator. And I think it's going to need a regulatory push for it to happen. But I say going into a building and achieving seamless connectivity should be no more difficult than stepping off of a plane in Spain and finding you can still make calls and your Google Maps still works, and we're not there. And I feel it needs a regulatory push, but the technology is becoming more and more affordable, and so there's opportunities, not just rural, but in building hotspots. So let's watch this space.
Yeah, I think Mark, eSIM is explosive, or is very powerful for this, and being able to have your operator, your MNO, your public SIM on your device, and being able to scan, say, a QR code and pick up an eSIM for an event or a particular, and then it can expire. So it's a very easy way of managing onboarding people to a private network. A neutral host is another very powerful feature that allows you to kind of federate your private network amongst others who it would be great if, as Mark's saying, it needs a regulatory push just to say, come on guys, these small communities are not going to drag an EE or a Telefonica or a Vodafone. We're not going to bring them to their knees. This wireless connectivity is kind of how our societies, how we kind of organise ourselves. So it's a great shame that there are communities that do not have the connectivity which they need. You can't order online. You can't scan something. You can't get part. Wireless is important.
There's another question from the back, Tom.
Yes, Dominic from Barn. I think the majority of the questions have been answered, but just for the benefit of the audience, really. We are in a situation where working with rural communities, sure, fibre is the way to get deep into the properties and get them all connected, but we see connectivity as a whole, and 5G and 4G is part of that. So we've been researching whether we can put our own private 5G network into these communities and then have an eSIM that they could sign up to with us, for example, and then as they go elsewhere, they can connect back. So I think we probably need to catch up after this, and we won't have the conversation now, but I think we hit the same barriers. There was no way of us trying to find a financial model that would work for this. The radios are expensive, but we have a network that covers a huge, vast rural area with dark fibre. We would like to put some 5G radios at the end of that, but at the moment, we've not been able to. I mean, we've made inroads into some, innovations and innovation region work, but ultimately, I think that we want to be a part of that journey as an altnet with some fibre. Let's go. So yeah, we'll talk afterwards.
That was more of a statement than a question.
Yeah, sorry.
Well done. I'm not complaining. I said there was some
Yeah.
symbiotics in this one. Izzy.
Hi, I'm Izzy and I'm representing Excelerate Technologies today. I didn't realise I had a video. So, Accelerate's been around for about 25 years, providing bespoke connectivity and data solutions to our customers. The team works closely with the customers, so we tend to bring them in for workshops at the beginning and find out exactly what their requirements are. And then we build a mixture of solutions, so we do hybrid connectivity, so a mixture of satellite and LTE 5G networks. And we also do little bits of fibre, but not quite so much. That's where we tend to come to you guys. We also do systems integration of our own products into other people's, and we do end-to-end deployment. So we're kind of somewhere between a systems integrator and an R&D developer. We have 24/7 support in-house, so all of our services have 24/7 support. If anything was to go down, primarily because we work with emergency services, we need our networks to be resilient, we need them to be always on, so there's always someone on the end of the phone. Our head office is in Cardiff, so we're based in Wales, but we operate globally. We've got offices in Middle East, Australia and Europe as well, so we do quite a lot of stuff in the Middle East. And we have a roaming sales team who work between the UK, Middle East and wherever else they need to be. So our mission is to put the right technology at the edge of every application. As you can see from the picture, we do a lot of emergency services stuff. A lot of the products that we've developed have come from someone coming to us with a challenge that they don't have a product or a solution for, and they're not the right people to be developing it. So they come to us and go, this is our problem, and we sit down with our technology team and we come up with a solution that fits that particular sector. I'll go through some more examples a little bit later on, but these are some of the other sectors that we're working in as well. Each sector has its own requirements, so this is why we have to do our workshops at the beginning, because although the technology might be the same starting point, everyone is coming from a completely different perspective. So either we need to understand their requirements, we need to know how we can fit the solutions into them, and they need to also understand where our technology is coming from. So we don't just rock up with a piece of equipment, we need to know that that's the right thing for that particular solution. In some cases it's a quick fix if we've already got something that exists. So for example, if another fire service comes to us, we've got solutions that are already ready, they're already proven, but it could be that someone comes with a completely new thing and it takes months of back and forth R&D. For example, some of our command and control units, that takes lots of bespoke requirements, and that also changes throughout the projects. As you can imagine, we develop something for someone else, someone sees it online, they want it in their trailer as well. So similar kind of topic to other people were discussing earlier, the community engagement is a big thing for us, because without our customers giving us the feedback, then we don't know what's the right thing for them. Now I'm going to go a little bit more into detail about some of the stuff that we do. It's broadly grouped into connectivity, services, integrated solutions, support management and R&D. So Accelerate's reputation was initially built on providing satellite broadband, which is where it all started. We still do satellite broadband. We do a mixture of fixed and moving parts, so we can do connectivity on vehicles, we do them on vessels, and we also do portable solutions, depending on the particular situation. And then we've also branched into cellular, so we do private networks, and we also optimise public networks, working with other partners as well. Our integrated solutions include the use of our own technology alongside our partners, off-the-shelf components, and taking the entire challenge away from the customers, building an end-to-end solution. And our maintenance and support, as I said before, 24/7, 365 days a year to manage any issues. And we also do training and maintenance on equipment as well. So depending on the customer, if it's, for example, a port, they might bring us inside so that we can do training for everyone on site. This is how to use the everyday equipment, and then we might do another training session with the IT team. This is how to use the specific stuff, and then we'll come back and do the maintenance inspections annually as well. And R&D is probably the biggest one. It's the one that gets us all most excited. It's the new challenges that we haven't come across before, or it's the challenges that no one's solved before. We do that with our customers, and we also do that as part of government-funded R&D projects. We just kicked off a project, which is a UK Space Agency funded project, developing a new satellite antenna. So that's for on-the-move connectivity. It's going to be a 20cm panel, which will be able to be mounted on anything moving, and that will link to LEO, GEO and MEO satellites. So it will give a whole host of different satellite connections from one thing, so you don't have to have a ton of different antennas on there. These are some of our products which are most popular. I won't bore you with all of them, but I'll just go through these ones. So this is our Hybrid Edge appliance, which is a hybrid bonding router. It was initially developed for ambulances, so to give a bonded network which brought in satellite and cellular, bonds them together to give you the network capability of both of them. So instead of having a hybrid switching one, which is quite common, where you might have a satellite link and a cellular link, and then if one drops, you ping onto the other one. This adds them together, so you've got the capability of both of them, and then if one drops, you don't have to wait for it to fully drop and have a gap where you wait for the next one to come along. This is our Excelerate antenna. So this is a optimization antenna, so you put any old SIM card into it, you put your normal 4G SIM card, whatever your phone carrier is, and then it's got directional and omnidirectional antennas inside it, so it hooks onto the connection that you've got, and then as you're on the move, if you're moving away from the cell tower, then you've still got a connection further away. And you've still got the higher bandwidth that you tend to lose as you go further away from the mast. So one example of this one has been, we took it offshore, we stuck it on a ship and took it offshore, and it was still just on a normal SIM card, I can't remember whose it was, O2, but it was the one, and it worked 60 kilometres offshore with a video stream. So these are very much used in emergency services at the moment. This is our UAV streamer. So this was developed around the time that drones really became a thing, and they started being used a lot in business operations. And the challenge that everyone was having was that the person who's controlling the drone can see what's on the screen, and they can see what the drone can see, but no one else around them could see what was on the screen unless they're all crowded around, or people are having to make WhatsApp video calls to stream back to control centres and view the screens in front of them. So the UAV streamer plugs into the controller, and then it uses our streaming software to optimise the feed and then stream it to our servers or to the customer's servers, and then that's available on our Extreme app or online on the website. This is our Links Hub, which is a portable Wi-Fi hotspot. This particular variant is bright orange because it's used for fire services. It is a dual SIM Wi-Fi hotspot, but it's also got satellite capability, so we can plug satellite into it, or you can just use it for SIM. And this one, it goes into the fire engine, it charges, it's always docked in there, and then as soon as they get somewhere, they lift it out. It's got batteries in that last as long as they need it, and then it's pinging out Wi-Fi, and you can have multiple Wi-Fi networks on there if you want. You can have management on one network, your general fire service on another network, and then guest access if you want to prioritise the data on there. And then this one also has the funky lights on there, so if they need to send messages back and forth, which does have a practical element because you can set it up in a certain situation. So if you wanted to say, if it's flashing red constantly, everybody get out the same area, and so, or you can set particular messages if you wanted to say the kettle's boiled or something like that. We also have a mixture of cameras. So this is a body-worn camera, which is used quite a lot by police. We also have situational awareness cameras, which are easily deployable, bigger cameras. And they all use the same Extreme software as well, so they will stream the video footage back. This was developed at a time where video streaming on body-worn cameras wasn't a thing. It was very much you had a SD card in there and then you downloaded it. It's much more common now, but we've been developing the software so it's optimizing the data. It's also got GPS in there and mission critical like buttons, someone's down, immediately get here right now kind of thing. This video just shows an example of our bonded connectivity on the move. So this is showing long-range cellular at the top through the Excel dome into the hybrid edge, another cellular connection directly in, and then a satellite link that can all be bonded in together. And that can be then used in any vehicle or any fixed site if you needed to. We've just finished fitting this onto Dorset Steam Railway. So it's providing cellular and a OneWeb connection so that they've got full connectivity on the train and for passengers as well if needed. And we've also deployed it on multiple other modes of transport as well, so anything from IoT devices on big lorries if they need to see exactly what's in the containers or they need to see the if anyone's smoking in the cab, anything like that, then that can also be routed through the same kind of thing. This is an example of some of the projects that we have been doing hybrid connectivity and more kind of 5G connectivity on. 5G Rural Dorset, the second one in, was one of the DCMS 5G test bed and trials projects, which is where we managed the rollout of coastal 5G. So that was our first real dive into private 5G, and that was providing it again for a lot for emergency services. So we did police ribs and emergency response. So first responders have an app on their phone, so if they get called to a site, they have an app, and it gives them a message that's come from the call handler to say, this person's been injured, this is what's wrong with it. They can't access the message until they get to the site. So they get to the site, they get to the person, and then they need to download the message to say what the call handler's had. They then have to run back up the hill to get a signal, and then they have to come back down, and then if they need to call the helicopter or something, they have to run back up the hill and get a signal. So that was one really good thing to come out of that project, is that they were fully connected. They had, I think they had XL domes on top of their vehicles, and then it meant that they could connect to the networking that way. And this is just some more examples of our larger scale projects. So this is where Northamptonshire Police and Fire joined forces to have one single network that works between them, so they can work seamlessly between them. So we delivered a custom bonded network of satellite and cellular. You can see the XL dome on top there and satellite antenna on top there. So Excelerate installs other people's satellites. We're a reseller for Starlink and OneWeb, but we also have our own satellite network as well. And we also fitted integrated cameras, drones and CCTV into the vehicles as well, which are all brought together under our digital dashboard management interface. So which is where we pull everything into one system, it's all integrated, it all works on one button, which means that when the fire service or the police or the ambulance turn up, they don't have to worry about how to turn it on, they don't have to worry about how to configure it, it just all works. In a similar one, this is Hamad Medical in Qatar. So this command and control vehicle, we don't build the actual vehicle, it comes from Mercedes, and then we fit everything out inside it. So this one was built for the Qatar World Cup, and it was shipped across for their situational awareness and their emergency response in case they needed it for the World Cup. It also has cameras, drones and CCTV in there and video streaming, so it can be used as a command centre, and then it can also talk back to their more fixed bases. So we fished out all the digital systems in the vehicle, and now it's being used by the emergency services ongoing. And unlike all of our command and control vehicles, it works off 2 buttons. So they turn up, they press 2 buttons, and the side comes out, the antennas go up, the screens turn on, the management interface comes up, the drones turn on, everything is just ready to go. And then the interface in the actual vehicle runs on just drag and drop. They can drag whichever feeds they need. So everything is all on the best user experience that we can possibly give them so that they can do their jobs the best they can. I think this is the last one. So we've just finished this project for EDF, and then we delivered 9 trailers in the top left there, which are emergency response trailers. So these are based off-site, so that if there was to be an emergency and there was to be some kind of issue with radiation, then the site's shut down or something goes wrong and the whole site's cut out, it's got no power, it's got no comms, it's got nothing, then these trailers would be brought to site. They would be left there and they would provide the comms, they would provide cameras to see what's going on. There's tethered drones on there, so you can put those up. They'll run 24/7 for as long as they need to. And then that gives EDF the knowledge that they've got a full backup system, and it's kind of in response to other things that have been happening around the world with other nuclear sites. So it's there as a just in case. Hopefully won't ever be needed, but they've got them all around just in case. And again, they run off 2 buttons. 2 buttons go, the whole thing pops out, it gets parked on site, and no one needs to go back to it again after that. So, as I mentioned at the beginning, our mission is to put technology right at the edge of every application, and our team is really passionate about providing connectivity to people that don't have access, especially where it makes a big impact. Like a few other people here, our team is really local. I'm not, but the rest of the team is based in Cardiff. All our R&D is in Cardiff, all our technicians are in Cardiff, everything is built and shipped from Cardiff to wherever else it needs to be around the world. So even the big ones that went to Qatar, they were built in Cardiff and then they were shipped out after that. That is all from me. Thank you.
Any question? Flashing blue lights and everything, come on. No?
Yeah, we'll work with you too.
Am I allowed?
You're always allowed, Tom.
Can I just say that was absolutely fascinating. I thought that was really interesting insight into that part of the industry and what you guys are doing. I think it's amazing. So, question is, are you working with National Rail Services? Now, this has obviously come up in lots of different conferences. Everybody travels on public transport and so on, and connectivity isn't very good. Obviously, what you're doing is very specialist, but what about a partnership with National Rail Services to improve connectivity on trains?
We are, but there is a lot of regulation around National Rail
Okay.
on train services. We're having conversations with them, and that's definitely, we can do the same solutions that we've had on steam railway and stuff like that. It's just the regulations to put something on a train is horrendous.
Okay, understood. But yeah, fantastic. Thank you.
Thank you.
Dominic, you get the last job.
Last job. Is everyone still awake? After that, of course they are. Of course they are. Because he did a great job. I shouldn't do her down. We worked together for a while, so that was a joke between her and I as much as anything. Yeah, so I was the one that said a cuckoo in the nest. My get out is that I came from the fixed background originally. All right, so I've worked at some of the same companies some of the people in this room are from, but I'm now in the mobile domain. My name is Dominic, I'm head of network operations at Jet Connectivity. It's a very grandiose title. It's a grandiose title because it assumes that I've got a massive network to operate. Right, that's not always the case. I said to someone earlier, if I have a day when I've got 50 SIMs active, it's a busy day for me. Okay, because what we're doing is private 5G and a much smaller sort of footprint, as it were. So I'm going to start this with a video. Hopefully it makes you, gives you a little bit of a better feel about what we do at Jet, and I hope it works because the slides being in this order with the video first is entirely my fault and I screwed it up. So here we are. Here's it going to go. So I hope you feel, well, it has some music, it has some drones, right? It's pretty cool, right? So it's how I generally look at these kind of videos. But yeah, a little bit about jet connectivity and enhancing rural connectivity. I'll tell you a bit about who we are. We provide pop-up 5G networks. They extend the capabilities of networks that already exist or our own. There's using a vast can be used in a vast array of different use cases. Particularly ones we're looking at is offshore safety around wind farms. You'll see the big yellow floaty thing at the start, right? We've got one of those going in the water, that one in fact, imminently. That represented an entire 5G network on a 33-ton maritime buoy that we're going to put at sea. That's targeting offshore safety, wind farms, that sort of thing. Disaster relief, so we built some trailers that are pop-up 5G networks that allow us to reconnect communities that are maybe lost due to outages on networks, that kind of thing. And as you saw right at the end there, agricultural use cases on farms as well. But a super eagle-eyed on you, that lady there is in that picture there, because she was also working with us at that time. But yeah, so we will have a shared background, of course. Being telco is very small. Right? Okay, cool. So a little bit about jet connectivity. Really maritime focused, all right? The founder of the company, the yachtsman, I think he was off the Fastnet somewhere off Southern Ireland, decided that he would magically lose all power and comms on his yacht, or the yacht he was sailing on, I should say. He would like a yacht. That comes when he managed to exit. But he was off the Fastnet, and he said, there's no connectivity anymore. Why can't I just build a maritime 5G network? Well, there's a couple of hurdles there. Firstly, you've got to build the yellow floaty thing, and secondly, you've got to build the telecoms infrastructure around it. But the formation of the company basically started like that. There was in Lulworth Cove, on the far left-hand side, there was a 5G UE, so a SIM card in a box, connected to a base station on land, providing a floating mesh network at sea. It was in Lulworth Cove. I'm reliably informed that buoy did actually sink and was raised, but such is life with the sea. In 2022, we got some contracts in place to allow us to do some feasibility work and to build a design for what we call the big buoy. The big buoy was built, well, two of them in fact, in 2023 and 2024. And to give you some idea of size, that thing is 22 metres tall and 33 tonnes in weight. Each corner of it weighs 6 tonnes. Not only did we build the telecoms aspect of this particular deployment, we also built and designed the buoy ourselves. So it's a big piece of kit. It's got 24 solar panels and it is overpowered. So we can put things on this buoy as well. In parallel to that, we launched a living lab in Grimsby in 23, and we proceeded to sell 5G radio sales to a variety of customers. It's no secret that we're partly defence funded. So the box that you'll see there in the bottom right-hand corner is a box which is a 5G network in that box, but it's also squaddy proof. Love them as we all do. This thing needs to be particularly tough to ensure that it can survive the problems of combat. Okay, and this has got special kind of connectors on it, and is designed to be used by a squaddy in the field to have a pop-up 5G network where today he doesn't have one. It's also man-wearable to a degree. It's 13 kilos, so you can put it in a backpack, but it is portable, and it does run by itself. So the kind of industries are in. So we looked at the ultra-remote pop-up communications that we talked about there. Some of the trailers, we talked about the rapid response for the networks, putting a network where there isn't one today. And on the buoys themselves, because they are so big, we can mount a lot of stuff that does data gathering within the field for agriculture, aquaculture, that sort of thing. You will also have seen what most of us quite get a kick out of, the drones, where we were flying the network up a hill and stop, and popping up a network where one didn't exist today. As we say here, rural search and rescue, very difficult, relies on teams, helicopters, those kind of things. It's very difficult to do. Anything which is that remote becomes very dangerous, very expensive, and our technology is meant to alleviate that by putting equipment either in place or drone mountable and flyable to allow you to get to that place more quickly and more safely. Also, we have no way of getting phone signal up there. Rescue teams can't communicate, and indeed people can't communicate in those situations. And sometimes when a disasters happen, one of the most important things is for everyone to get back into business as soon as they can, be it calling NHS, be it letting them know their family's all right, be it running payroll for someone down the hill who works your business. All of these kind of things are the bedrock of what communication allows for and provides for, but we do need to improve that connectivity in that rural location. The mesh networking, as we said before, as many people pointed out, you get to the edge of the network and then the network stops. Some of the private 5G mesh networking that we've developed allow us to hop further than that point over part of the 5G protocol called Integrated Access Platform. And that allows us to use the 5G frequency to get further. Of course, it's line of sight, of course, there's a distance problem, but you can solve that by some very clever work on the antenna, changing frequencies, and perhaps also boosting power where you need to. So, what does the pop-up network provide? Well, traditional connectivity, as we know, is very infrastructure dependent, but we're rather infrastructure free, right? We have quite small pieces of equipment, they're battery powered, you can really carry this stuff. You don't need a fixed installation. I've been on the side of a hill, I put a speaker stand up with an antenna on it, there's a battery there, and then I have a 5G network where there wasn't before. If I want the backhaul, I plug into something else. I can plug into the fibre, I can hop via the IAB, or I can stick a Starlink or OneWeb something into the back of it, and suddenly I have a network, fully end-to-end. We can scale it by putting more nodes in place. It's very quick to do, and it's 5G, so it is fast. So talking about some of the deployments we've done, this represents, on the right-hand side here, a trailer that was recently gone up to Scotland. There seems to be a lot of work going on in Scotland, but this is part of the Tay Cities project, Tay Cities Fund, I think I should call it, whereby we were demonstrating 3 or 4 particular use cases that were applicable upon a disaster hitting. The first being, how do I, as a user, as a user on this service, contact the NHS for a non-blue light service and get some advice, speaking to the doctor on an app. This allowed us to do this where all the rest of the connectivity was down. This particular trailer is fully solar powered, and it runs for a day without any form of backup whatsoever, and it recharges during the day as well. It has a telescopic mast that goes up to about 4 or 5 meters, and on the trailer itself, it's running a full 5G network, private 5G network, in complete isolation. It has a Starlink to get back to the rest of the world. If something else happens to be there, it can plug into that as well. And there I am. There you go. This is us doing the video call using the trailer with the door open. As you can see, it was in Dundee, where that current buoy is right now. It was a very cold day last week, so this was our launch last week. The second real-world application, this is for agriculture. So, as part of the River 7 Advanced Wireless project, we were commissioned to put together a trailer for Hartbury University. That's a farming university in Gloucester. It culminated in the top right-hand corner with me streaming Clarkson's farm on the farm. Okay. What does this trailer consist of? Again, it's a 5G base station, a full private 5G network. Within that trailer, it backhauls through Starlink, and again, this trailer will run for a day without having any problems. It also has a couple of other bits and pieces on it. First, it's a 10-meter mast, okay? So that means that it's got quite a long range and you can see quite far, point to point. It also has what's known as a LoRaWAN gateway on it, a LoRaWAN gateway to allow for sensors in the field to connect back to it and then out to the rest of the world with all that very valuable farming data that we have there. We did a demonstration up at Tarside. This is in Scotland. This was our search and rescue demonstration. In this, we had a network on the side of the hill that was extended by flying under a heavy lift drone this Geno B, so this base station. We flew it up the hill. Someone was, I'll be very honest, someone was hiding in the bushes and come out with the antenna and plugged it in with the battery. But then we had a further network further up the hill, which allowed us to then simulate search and rescue missions in that area. That would allow, or de-man that particular search and rescue effort because we're doing everything with drones and we can find people. This really adds to the safety of people climbing problems you might experience whilst up in that kind of environment. And finally, the buoy in Dundee. As I said, this buoy is very big. Okay, it's going to be floating in the water in the next couple of weeks. If you follow the news, it might well be featured in that. when all goes well. I'm sure it will. This is, like I said, a 33-ton maritime buoy. Inside it is that entire 5G stack. It can link via IAB to other nodes on the network, and it will be moored in the Tay River in the coming weeks. The idea for that is we provide multiple use cases. One of them that we're thinking about doing is including a drone recharging station on it. Because it has so much power and it's so big, we can attach extra equipment to it. So a drone could land on it, recharge, and go away and do the rest of its mission, all whilst being covered by this 5G bubble. So that's what we're doing here at Jet. Yeah. I think the conclusion, as much as we've reached already today, we're bridging that digital divide, especially in some of the areas whereby you have no connection today, or you have limited or damaged connectivity. If you imagine when the network goes down, people still need to do their day job. People still need to be able to provide, reassurance to their family that they're still there. They need to be able to get advice from doctors. They need to be able to contact their loved ones and do their business. It allows us to deploy in rural not spots, but also where you do need that data, you can make safe decisions based upon that data that's coming back from these rural not spots that previously you didn't have any connectivity in, and particularly useful in the agricultural world. So, any questions? No, there are. I'll hand you back to you, sir.